Okay, I need you to pull out your notes for Chapter 9 and also your periodic chart and your polyatomic ion chart to follow along. We're going to fill in the notes for Chapter 9.4. So we're kind of backtracking because we did 9.5 in lab. So this one right here. We're going to learn about 3 types of formulas. Structural formulas are first. Structural formulas show you the types of atoms, the exact composition, basically how they're put together, and what kind of bonds they have, the arrangement of the chemical bonds. So here's a couple examples. This is this one right here. This is the structural formula. It gives you 2 carbons and 2 hydrogens, but it shows you it has a triple bond right there. And here's another structural formula. There's a bunch of H's at the end of all these C's. Again, 3 carbons and hydrogens all around, and then a structural formula you're used to seeing, H2O, for water. So you can see that it gives you the types of elements that you have, carbons and carbons and hydrogens, or over here oxygen, and exactly how they're put together, how they're arranged. It gives you the most information right here. Now molecular formulas give you the second most information, and these are the ones you're used to seeing in bonding, not bonding, but in balancing equations and whatnot. So let's look at this one. This is the structural formula. So what would its molecular formula be? Now the molecular formula would be C2H2, because it just lists the types of atoms, 2 carbons right here and 2 hydrogens right here. And this is what you're used to seeing in chemical formulas or balancing equations. We're going to use MF. I'm going to say what's the molecular formula, and EF we're going to use for empirical formulas. And that'll become more understandable when we learn to calculate all these things. So the molecular formula gives you the types of atoms and just the number. So what's, oh, I forgot to put the hydrogen there. What is the molecular formula then for this one? Well, this one would be C3, because there's 3 carbons, 1, 2, 3, and H8, because there are 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens all the way around. And the molecular formula for the other one is just H2O. All right, now what about empirical formulas? Empirical formulas give you the least amount of information, but they are the simplest whole number ratio. They're just taking these things and it's like simplifying a fraction. If I can divide by something to make it simpler, I will. So 2 and 2, obviously they can both be divided by 2. So the empirical formula for this one is going to equal CH, because 2 divided by 2 is 1 and 2 divided by 2 is 1. What about this one? What's the empirical formula here? Well, that's still C3H8, because I cannot simplify it anymore. So sometimes the molecular formula and the empirical formula will be exactly the same thing if I cannot simplify it. And what about this one? What is the empirical formula for this? It's just simply H2O. Again, I can't simplify it. So that's what you need to fill in for your notes. Now we're going to move down to 9.5. We did this in lab. We went through learning percent composition. You will have some percent composition homework on Tuesday. So we were going to do the seat work right here in class, but I'm going to do it for you now as a review. So you will need to know how to do this for your homework on Tuesday. So first we have to figure out what's the formula for ammonium phosphate. We have to look it up. Ammonium is a polyatomic ion, NH4 with a +1 charge, and phosphate is a polyatomic ion, PO4 with a -3 charge. Put the charges on the top, swap and drop. So this becomes NH4. Have to put parentheses around the whole thing, and then we bring that 3 down. So that 3 goes down here, and then PO4. That's the formula. Now when we're finding percent composition, and I don't tell you any information about it, you're going to pretend you have an entire mole of it. So we list all the atoms, nitrogen, hydrogen, phosphorus, and oxygen, and first thing we have to do is count how many we have. So remember, you have to distribute this 3. So we're going to have 1 nitrogen, 12 hydrogen, because 3 times 4 is 12, 1 phosphorus, and 4 oxygens. And the next thing I need to do excuse me, is to go look up the molecular mass, the molar mass rather, of each of these atoms on a periodic chart. So I try to pull one up. There we go. So look, there's nitrogen, 14.01. I want 2 decimal places. This one has 14.007. We're going to round that up to 14.01. So that's nitrogen. Hydrogen is going to be 1.01. Phosphorus is going to be 30.97. And you can look on your periodic chart to see all these. And let's see, we had nitrogen, oxygen, phosphorus. And I think that's all. NH4PO4. All right, so back to this. So let's write all those numbers in and do the multiplication. So nitrogen is 14.01, hydrogen is 1.01, phosphorus 30.97, and oxygen is 16 for oxygen. We multiply them. So 14.01. Oh, sorry, we have 3 nitrogens. I wrote 1. We have 3 nitrogens. If y'all were in class, you probably would have yelled at me. So let me erase this and put the correct number. 3 times 14.01 is 42.03. There we go. And then 12.12, 30.97, and 64.00. I want 2 decimal places for the molecular masses or the molar masses of either molecules or atoms. Now we add it all together, we get 149.12 grams per mole. This number right here is the molar mass. It's the mass of 1 mole of ammonium phosphate, and that would be 6.022 times 10 to the 23rd molecules of ammonium phosphate. It's also going to be our whole. So to determine the percent composition now, we're going to divide all the parts by this whole of 149.12. And when you're doing percentages, you also have to multiply that number by 100. Okay? So we do that, and we end up with 28.19%. Notice I put the percentage there. It needs to be there as the unit. 8.13%, 20.77%, and 42.92%. Now, this right here, when I ask for percent composition, these are the final answers. This particular problem would probably be a 5-point question. You'd get a point for the molar mass and a point for each percentage. Now, using that information, if I had 74.1 grams of this stuff, how many of the grams would come from the hydrogen atoms? Well, I take 74.10 grams of ammonium phosphate and I multiply it by the percentage that is hydrogen. So what percentage is hydrogen? Hydrogen is 8.13%. We take that 8.13, we turn the percent into a decimal by moving the decimal place 2 places to the left. So we get 0.0813. So 0.0813. And that answer is 6.02, because 3 sig figs, grams of hydrogen. So what does that mean? If I have 74 grams of ammonium phosphate, 6 of those grams comes from the hydrogen atoms inside that molecule. All right, we're going to be covering calculations with empirical formulas in class on Wednesday. I also wanted to show you something with the on the Prezi. So let me back this up just a smidge. There we go. This has some pictures of some more structural formulas right here, just different kinds. And this is a structural formula of a lipid, of a fat. Notice that we got a lot of information here. I don't know what the molecular formula is. I'd have to count up all the hydrogens and carbons and oxygens in this molecule. But this side of the molecule is not polar. It would be called hydrophobic. And this side of the molecule is polar, hydrophilic. But you don't have to worry about hydrophobic and hydrophilic. You just have to know, this is a structural molecule, a structural formula. It lists everything. And then let's move forward. Here's some more molecular empirical formulas. The molecular formula here is P4O10. I can divide both of those numbers by 2 to get P2O5. That's the empirical formula, the simplified ratio. C10H22, simplifies to C5H11. And then this one, C6H18O3, all those are divisible by 3, so I simplify it down to C2H6O3. So these are just examples of turning molecular formulas into empirical formulas. Now here's another one. Just these are all empirical formulas. But notice that I gave you this question. I put this one on the paper, and then this one also has benzene as having CH as its empirical formula. So we're going to go back to our notes for just a second and back up to the top. And notice I'm going to add just one more thing in there for you. Okay, C2H2 is a molecule, methane, ethane, ethene, ethyne. It's called ethyne, and its molecular formula is C2H2, and its empirical formula is CH. Well, benzene, its empirical formula is also CH, but let me show you what it looks like. It's got 6 carbons, and we've actually seen this before, and it's got some double bonds listed, and then hydrogens coming off of each one of those carbons. This molecule displays molecular resonance because those bonds could have been on any of the carbons, those double bonds, every other one. So really it's not double bonds and single bonds, it's the average all the way through. This is the structural formula for benzene. The chemical formula, or the molecular formula rather, would be C6H6 because there are 6 carbons, 1, 2, 3, 4, 5, 6, and off of that 6 hydrogens. So the molecular formula is C6H6, and then if you simplify that, you just get CH, and that's the empirical formula. So what do you see? You see that you can have an empirical formula for one molecule be the same empirical formula for a different molecule. We are going to be able to figure out which is which when we do the math, but we'll go over that in the next class. And there's one other thing I was going to show you on this Prezi, and it has to do with, so this is some more structural formulas right here in empirical formulas. Let's get past the percent composition here. There it is. I have this worksheet I'm going to email to you, and it's some in-class percent composition practice, which we're not going to get to do. But I did do the seat work for you that was in the notes. So this is just if you need additional practice, you can do these. Find the percent composition of these molecules, answer a question about it. There's just a few, like 5 right there. But also embedded in the Prezi is the answer key to all of those. So you need to make sure that you can understand how to do all of these, okay? When we get back, we'll be moving forward from this point. I'll see you